All right, so this is more angle arc theorems, and this is 10.6 in your books. Not as long as last section, so that's good. All right, let's start off with our objectives. You will be able to recognize congruent, inscribed, and tangent chord angles. You will be able to determine the measure of an angle inscribed in a semicircle, and you will be able to apply the relationship between the measures of a tangent secant angle and its minor arc. Okay, so let's start with congruent, inscribed, and tangent chord angles. Theorem 89 says if two inscribed or tangent chord angles intercept the same arc, then they are congruent. So if you look, we are given angle X and angle Y are inscribed angles intercepting arc AB. So because they intercept the same arc, see how this one kind of intercepts AB, and so does Y. Because they intercept the same arc, we can say that their angle measures are congruent. Okay? And vice versa. Okay, congruent, inscribed, and tangent chord angles. Theorem 90 states that if two inscribed or tangent chord angles intercept congruent arcs, so if we know that arc AB is congruent to arc CD, then these angles are congruent. Okay, so because the arcs are congruent, that means that the angles that intercept those arcs are congruent, even if it's like this one where it's a tangent chord. So again, another thing to keep in mind that's extremely important. The tangent chord ones, for whatever reason, tend to throw people off. I think it's because it's not readily apparent as an angle. So that might be one that you want to focus on. You know, if it helps, highlight the angle. You know, you really can't see it with my yellow pen on there, but highlight the angle, draw it in. Yeah, sometimes that helps. Just trying to think of ways to help you guys out. So in this example, if we're given line ED is tangent at D and arc AB is congruent to arc CD, then we may conclude that angle P is congruent to angle CDE. Easy enough, hopefully. Okay, and angles inscribed in semicircles. Now this is actually kind of fun. You can do something on your calculators on the TI Inspires to kind of show this. But Theorem 91 states that an angle inscribed in a semicircle is a right angle. So if you have a diameter, no matter how you try and draw this triangle, because this is really a triangle, right? The angle is always going to be the right angle. So no matter where you move this vertex along here, it is always going to be a right angle. Something a little neat. So in this example, given that AB is the diameter of circle O, remember that if it's the diameter, it means that it cuts a circle in half, making two semicircles. Then we would know that ACB is a right angle. Okay? And a special theorem about tangent-tangent angles. So that is the sum of the measures of a tangent-tangent angle and its minor arc is 180. So if you added the measure of this angle here and the measure of this arc here, it's always going to add up to 180 regardless of if the vertex was, say, here. You know, this would be 180. If you move it all the way back here, it's the measure of the angle and the measure of the minor arc is always going to be 180. That can be a pretty useful theorem, as you'll see in some of the practice problems. All right, so in this example, segment PT and segment PS are tangent to circle O. So again, that means that this and this equal 180. And the way you can prove this, if you draw from the center of the circle two radii that go to where the point's tangent, because remember, these create 90-degree angles. Okay, and then you could, if you had to, prove it by making two right triangles and proving them congruent. Just a thought. All right, so let's try some practice problems. What is the length of a chord that cuts off an arc 60 degrees in a circle with a radius of 5? Now I know you have other ways of doing this. I'm just illustrating how there are multiple ways. So what we can do is we can take and draw in that chord. We can determine that the inscribed angle that determines the arc. Okay, so the measure of that angle is 30 degrees. Because remember, if the inscribed angle, if the vertex is on the circle, it's half the measure of the arc. Okay, we know the length of the radius, so if we wanted to, we could inscribe that angle by having one of its chords be the diameter, which makes it a semicircle, which gives us a right triangle. And if this is 30, this is a 30, 60, 90 triangle. Okay, and then we can use the 30, 60, 90 ratios to determine that the length of the chord, which is opposite the 30, okay, we said that that was 5, right? Remember 30, 60, 90? I'll put it up here. 30, 60, 90. This is x. This is x root 3. And that's 2x. So this is opposite our 30. So if that chord is 5, that means that the diameter, the hypotenuse, is 10. But that's the diameter. We want the radius. So if we take that, the radius of that chord would be 5. The measure of the radius is 5. Okay. All right, so let's try some more practice. Given line PYA and QW are tangents to this circle here. Okay. So, and arc WZ right here, because remember, if they don't put a middle letter in there, it's always going to be the minor arc that they're giving you, is 126 degrees. And arc XY is 40 degrees. Find the measure of arc PQ. So we're trying to find this right here. So first things first, we start with the measure of angle 1 is 126 minus 40, because remember, this angle is outside, the vertex is outside the circle. So we take the smaller one and subtract it from the larger one, which gives us 86, and half of that would be 43. And if this is 43, I can just change that. If that's 43, then angle 2 also has to be 43 because vertical angles are congruent. And then we could say that the measure of PQ, of arc PQ minus the measure of angle 2, which is 43, equals 180. Because remember, they have to add up to 180. So that should actually be plus. Something must not have come through. All right, so the measure of PQ plus 43 equals 180. So the measure of PQ equals 137. Okay. Well, that's it. Don't forget, there is one more video this week. Okay, there's 4 this week. So one more to go after this. You might find it interesting. All right, have a good one.